Hello, welcome to Astronomy Live. Tonight, I'm going to be webcasting the SDO spacecraft. In fact, that's what you're seeing right now. So, tonight we're going to take a look at the mystery of the missing sun on SDO. So, for the last number of days, has been observing the sun and seeing it appear to disappear. And some on YouTube are claiming that the sun is being drained by a mysterious object, and NASA is, of course, covering it up. Let's see, if I search for SDO sun drain on YouTube, immediately I get 667 results. Now, some of that refers to basically coronal prominence channels and things like that, but many of the top results refer to sun eclipses. Now, what could possibly be eclipsing from the sun from the perspective of SDO? Well, first, it's important to know that the SDO spacecraft, SDO, by the way, if you don't know, stands for the Solar Dynamics Observatory, the main spacecraft that is currently observing the sun 24 hours a day, or mostly 24 hours a day, because lately the sun's been going missing for a little bit each day. And there's a reason for that. Now, obviously, it's not the moon, because the moon can only appear to eclipse the sun once a month from SDO, unless you get a double solar eclipse. It's very, very rare. It happened a couple years ago where the moon basically seemed to drive over the sun and then reverse direction and go back the other way. That's a more complicated matter we can get into some other time. But the main thing that everyone's talking about now is the daily disappearance of the sun. So, not the moon, although one day, when was that? September 1st, was it? It was a few days ago. You had a double solar eclipse where two objects were eclipsing the sun simultaneously. And NASA put out a video about this and explained that that was indeed the moon and the Earth. Because SDO, unlike SOHO, unlike stereo, it is actually orbiting the Earth in a geosynchronous orbit. So, what we're looking at right now from my telescope is actually the SDO spacecraft. This bright dot right here, this is SDO, and the telescope is actively tracking it. The lines are streaks from stars. These are background stars that are streaking by as the telescope is tracking SDO. Now, SDO is in a geosynchronous orbit, not to be confused with a geostationary orbit. They're similar, but they mean different things. Geosynchronous simply means it completes one orbit in a 24-hour period. Geostationary, of course, means that it doesn't appear to move in the local sky, because it is not only completing one orbit in a 24-hour period, but its inclination is also zero. It's orbiting directly over the equator. Geosynchronous satellites complete one orbit in 24 hours, but they don't necessarily orbit directly over the equator, and SDO is no exception to that. It does have some orbital inclination to it. So, from the perspective of an observer on Earth, it's not actually stationary. It does appear to move in the sky, but from the perspective of observers throughout pretty much all the U.S., it basically is visible throughout the night, except when it happens to go into Earth's shadow. And that is actually what is happening right now. The spacecraft is in what we call eclipse season. So once a day, it will pass into Earth's shadow and then emerge out the other side. And as it does that, Earth is much larger than the sun from SDO's perspective. It's in geosynchronous orbit, so it's pretty close to Earth. It's actually about the same distance from Earth as the asteroid that we saw yesterday morning, and only slightly further away. So from its perspective, Earth fills up a much bigger portion of its sky than the sun does, and therefore you see this ginormous object appearing to eclipse the sun. There have been people claiming that this is all a cover-up, that this is not the case. In fact, some have been claiming that the sun is being drained. Something's going wrong with the sun. But because SDO's imagers are pretty much mostly extreme UV, those are the pictures most people take a look at, are the extreme ultraviolet images, that this mysterious draining of the sun is not a visible phenomenon, that it's not the visible light that is winking out, it's the extreme ultraviolet light that our eyes can't see, so you wouldn't notice anything going wrong just by looking up in the sky. That's their explanation for why people worldwide haven't been noticing the sun suddenly disappearing on clear days. But tonight we're going to take a look at the SDO spacecraft, which is what we're doing right now, and in a few minutes the SDO spacecraft is actually going to go into Earth's shadow, and we're going to watch that happen live. And what we're looking at right now is a visible light image. Now, normally, when I do astrophotography, I just leave the IR and UV blocking filter off and let the CCD accept every photon of light it can get its hands on. Because I use a catadioptric, you don't really get much in the way of chromatic aberration resulting from looking at a wide spectrum of light, like you would if I were using the refractor. But tonight, I've actually put the IR and UV blocking filter on, so we're only looking at visible light here. And you can see the visible light from the sun reflecting off the spacecraft, creating this nice little dot right here. But what's going to happen is it's going to go into Earth's shadow in a few minutes, and it's going to disappear. Now, at the same time, I suppose someone could try to claim, well, that's just proof the sun really is winking out. Well, a couple things. First of all, we can actually use these images with stars visible in them to confirm SDO's orbit, to confirm that SDO is orbiting the Earth the way that NASA says it is. And we can actually look at what the geometry of that situation demands in terms of the sun being eclipsed by Earth. We can also point the telescope to other geosynchronous satellites after SDO goes into an eclipsed state. And that's what we'll do. We'll take a look at other geosynchronous satellites that are not in Earth's shadow right now. And you will see that they are indeed visible. Now, if you're wondering what this gradient is, these are not the best images I've ever taken by any stretch of the imagination. I'm actually dealing with a pretty severe street light here near where the telescope is pointed, so you're getting a lot of glare from that street light. But SDO is a pretty bright satellite, much brighter than the asteroid that passed by Earth, because, of course, unlike the asteroid, SDO is shiny and metallic, so it reflects a lot of light per unit of surface area. And as a result of that, I can get away with just doing 3-second exposures, which is what I'm doing right now. These are 3-second exposures, and you can see the satellite is brightly detected, even at 1x1 binning, which is also why we're getting color data. We're not by 2 like we were last night. Because the way this CCD works, every pixel is assigned a specific color. It's very similar to a consumer CCD in the sense that it has a what we call a Bayer matrix over the CCD, and so every pixel is assigned a particular color, blue, green, or red. And so when you start binning the pixels together, you can't get color data because the green get grouped with the red, and the red get grouped with blue, so on and so forth. You can no longer decipher color data from the image, so it turns into a grayscale image. But when you're not binning the pixels together, when you're doing just full resolution 1x1 binning, you get this color data. So yeah, the street light is contributing lots of ugly green light to the image, unfortunately. But hey, it doesn't have to be pretty, it just has to be functional. So that's what we are doing tonight. Let me see here. Do we have any questions in the chat? I'm sure we do. People are probably terribly confused by what the heck I'm doing tonight. Let's see. So someone asked, so Steve Olson is wrong? No. Yes, Austin. Steve Olson is wrong. I'm sorry. Sorry to burst your bubble. But he's not even the only one. There are others. Chris Potter claims that he, I don't know, he just got this video claiming that it's a physicist's thoughts on sun energy draining. So we're gonna lay this all to rest tonight. I'm sorry to those, because I've been getting a lot of questions about this. Actually, I've been getting bombarded with questions from people who were, in many cases, previously fans of Steve Olson, asking me to address this, because they're waking up and they're realizing that some of these characters on YouTube are not telling them the truth, and you know, they're legitimately concerned about what some of their friends are thinking, saying, and potentially going to do as a result of, you know, when somebody tells you that the sun is being drained, that there's something wrong with the sun, if you genuinely, sincerely believe that, I mean, that's a cause for major concern, isn't it? So, and for WSO's part, they claim to be building, you know, well, they don't claim to be building. I've seen the video. You know, they're building a small underground bunker of sorts to store survival food and have ham radio and all this stuff. So, I mean, I don't use the term lightly, and I hate to say it, but it's reminiscent to me, and this was before my time, but I've seen, you know, documentaries. It's reminiscent to me of Jonestown, or maybe something that I do remember from my high school days, when the Heaven's Gate cult happened, and I was living out in Colorado at that time, and that was kind of a crazy day. So, you know, some of these cults are really dangerous. If they manage to convince you that, you know, something's seriously wrong with the sun and the solar system, hey, it's cause for alarm and panic, and, you know, then they can manipulate you into doing things you normally wouldn't do. So let me see here. We are at almost 2 a.m. on the dot Eastern time right now. Here we go. So satellite tracker just popped up. Now, I don't know how accurately satellite tracker is modeling the edge of the sun, whether it accounts for the oblate shape of the Earth precisely, but it does indicate now that we will have what we call loss of signal, LOS, in 2 minutes 13 seconds, meaning the satellite will go into Earth's shadow in 2 minutes, and now 2 minutes 6 seconds. So we're going to see orbital sunset here on SDO very shortly. And this is kind of cool even for me, because I've observed SDO before through the telescope, and, you know, done this sort of thing before, calculated its orbit before. But what I haven't really done is I've never actually been up at 2 a.m. to watch it to go into Earth's shadow like this. You have to catch it at the right time of year too. This doesn't happen throughout the year. This actually happens what we call eclipse season, twice a year, two different times a year, basically 6 months apart. The sun has to line up behind the Earth. Normally, for most of the year, the sun will pass above or below the Earth from SDO's perspective, and so it gets 24 hours of sunlight. But during eclipse season, you do have SDO passing into Earth's shadow and experiencing orbital sunset. And so we are now satellite tracker, Brent Goshart's satellite tracker program is predicting it'll go into Earth's shadow in about 50 seconds. Again, I don't know precisely how accurate that's going to be, depending on how well it's modeling the shape of the Earth. And there's also, I should point out, some delay in taking each exposure and actually downloading each exposure. I keep forgetting you guys can't see the camera control window because Google Hangouts has changed a bit, but there's some lag between each picture, each 3-second picture being taken, and each picture being downloaded. It basically takes a little bit longer to download than it even does to take the picture. It should be going into orbital sunset any moment now.
You don't. Okay. Good night. Take it easy.
Good night.
All right.
So it's starting to be eclipsed now by the sun, or sorry, by the Earth's shadow. And I think it is starting to actually dim. be interesting to see how well the timing of this eclipse will line up with the images from the SDO website. might be a few minutes longer than I thought to get into full eclipse here. I don't think Brent's program is terribly accurate at modeling the shape of the Earth. I think it's a little over-eager to declare a satellite eclipsed. We'll solve the orbit of SDO using these images and project that out and see what the actual geometry should have been. But it looks like yesterday, see, I'm trying to find the exact moment it went into eclipse. That's going to depend on let's see. Should probably be using helium here. It's a little easier to find what I'm looking for. But okay. So it definitely should be eclipsed by 7-degree separation, which this morning will occur at 6:27. So we might actually have a lot more time here. It maybe should definitely be eclipsed by 2:27 Eastern Time, which is about 12 minutes from now. Just looking at the images from yesterday where the sun went missing, and at 6:10 Universal Time it was still visible, but by 6:26 Universal Time it was invisible. And at 6:10 Universal Time it was Earth's, the center of Earth as seen from SDO is about 10.4 degrees. The center of the sun right now it's at about 9.3 degrees, so it may have to get a little closer. Hey, WTF Sky, good to see you again. Well, if he says you're his biggest troll, then you must be doing something right, right? Yeah, I think, Enrique, I think, so right now, satellite tracker claims SDO is eclipsed, but I think it's over-eager in declaring that. I don't think it gets the geometry quite right in terms of where Earth is, or how big Earth is as seen from SDO. For some reason, that math seems to be a little bit wrong. But I think you're right in terms of when it should happen. It should definitely happen by 2:30 Eastern Time. That'd be 6:30 Universal Time. I would share the satellite tracker screen, except it has my very precise location in it right now. So if I shared that screen, everyone would see exactly where I live, which, sorry, I don't really. It's not that I don't trust you guys, but some of you guys don't trust you, so can't share that. Yeah, we'll just hang out here and wait for it to happen. Now, let me see. I wonder if the latest SDO images have been updated yet. Sort of. There's the 6 o'clock Universal Time. Images seem to be up. Sun's still shining bright there. Oh, it's going into eclipse. Oop, it's vanishing. There it goes. Just a little bit of red light reflecting off of it. Just a red tiny dot right now. And it's still just got a tiny bit of red light reflecting off of it. It's just the faintest little red dot. Boom, gone. Totally into Earth's shadow. So there you go. SDO went into Earth's shadow and is now fully eclipsed. So any images that were taken as that was happening just now would show the sun partially eclipsed by Earth. And that's why you get those strange looking images that are floating around YouTube right now claiming that something's draining the sun. And now any images that are going to be taken after that point until it comes out the shadow on the other side, those are going to show just nothing. There's not going to be any sun there to be seen. And so that can lead to claims that NASA's covering up the sun, hiding whatever's being seen, whatever's there, that sort of thing. So to prove the sun did not actually disappear and that the satellite really is just in Earth's shadow, we're going to take a look here at some other. I'm going to stop saving those images now. So let's see, what else we got? Anything interesting? Oh wait, here's DirecTV. DirecTV should be in sunlight. It's a geostationary satellite. Okay. There might be more than one geostationary satellite in view here. Let's see what we get. Yep, there's a couple. So you can see this one's probably the one in the closer to the center is probably the DirecTV satellite I was going for here. This is DirecTV 5. So if you have DirecTV and you happen to be receiving from DirecTV 5, it's currently in the southwest from my position in Florida, 45 degrees high, azimuth 228 degrees. That's your satellite providing your TV. Kind of cool, huh? So as you can see, there are several different geostationary satellites in view here. And because they are geostationary, I can actually shut the telescope off right now, and these satellites won't really move. They'll still stay in view because they're orbiting once every 24 hours, so they stay stationary relative to the Earth's rotation. Because the thing you have to keep in mind, the reason that works, the reason that can happen is because orbital velocity the velocity necessary to attain orbit is with respect to an imaginary fixed point basically at the center of the Earth. And because of that, you can leverage the Earth's rotation. So if you launched from the equator due east, it's easier to get to orbit than launching the opposite direction, launching west, because you have to then not only reach orbital velocity, but you also have to counter the Earth's rotational velocity, which is was trying to carry you the opposite direction. You had that initial inertia, so you can leverage that inertia, which is why this is why Florida is a good launch site for the United States, because it's a very southern state and allows you fairly easy access to geostationary orbit, because you start off, say, about 27, 28 degrees north latitude, and so you launch east from there, so you leverage a lot of the Earth's rotational velocity. The closer you are to the equator, the more you can leverage that velocity. Now, if you were launching from, say, the North or South Pole, of course, the Earth is turning beneath you, but you're not actually getting to leverage any of that velocity. So it's a function of your latitude. And also, if you're trying to get to geostationary orbit, you have to have zero inclination. So if you launch due east from Florida, your inclination will be about 27, 28 degrees. So you kind of have to dog-leg it into orbit, and that takes a little more energy, but it's not as bad as launching further north. The further north you launch, the more energy it takes. So anyway, bottom line, obviously the sun is still shining. These satellites are reflecting sunlight. Okay, folks, you can stop the panic. Just because this is kind of interesting, I will save. I want to save one of these pictures here. DirecTV 5. Okay. I have to stop the exposures to tell it to start saving them. I wasn't saving these to the hard drive initially, but I'm going to save a few of these here, just because it is kind of cool. So, any questions? Oh yeah, should pick a helio viewer here. Here we go. Perfect. So HelioViewer, the 335 image, I think that's 335 angstroms, was taken at 6:16:51 seconds, and you can see the sun partially, in fact, mostly eclipsed. I'm going to save that. And then the 1600 image, it's almost entirely eclipsed by 6:18 and 16 seconds. So I'm just looking at the latest images that are available on the SDO site. And then by 6:18 and 54 seconds universal time, 1700 image shows that it's gone. So let me fire up the Sky Stacker. I just want to compare that with my images. Okay, I'm going to stop saving these pictures. I don't want to fill up my hard drive with DirecTV pictures. I'll let you guys continue watching DirecTV. No, I wasn't trying to make a pun, but pardon the pun. Da. So 6:18:54 seconds, it was basically fully eclipsed, and that is right when we caught the last glint of light from SDO. It was right at 6:18:54, and that's when the image saved. It looks like the image cadence I had, even though I was only taking 3-second exposures, it was about 10 seconds from picture to picture. Like I said, it actually takes longer for the picture to save from the camera than it does to take it, in that case, when you're taking 3-second exposures. So at 6:18:44 seconds, there was still a little bit of light reflecting from SDO, but by 54 seconds, it was just the last glint of light. And then by 05, it was basically gone. And that matches up perfectly with what we see in the latest images from SDO on the website. Now, if I refresh this page, they'll probably all go black here. No, I haven't put the latest images up yet. But yeah, I'm going to save. I'm going to save one more of these so that I have a reference of when it was still fully visible. Beautiful. Oh, latest images are just coming up now. So that one's the 211 image is now black at 6:25 Universal Time, as expected. So excellent. We got to see SDO go into eclipse, and we got to see that it matched up with the pictures SDO was taking at the time. All right. Any last questions? So Andrew Austin asked what time it went into eclipse. So it was a gradual process, but the last hint of light was basically that to... Sorry, I'm just trying to load up these images here, and it won't come through. Okay, so the last hint of light I saw with my scope was right at about 6:18 and 54 seconds universal time. There was just the faintest dot of red light, probably reflecting off one of the edges of the solar arrays at that point. And then from then on, it was more or less invisible. Might be just even a fainter red dot, almost buried in the noise of the camera at 6:19:05 universal time. But by that point, the cameras themselves that are on the spacecraft were probably fully eclipsed. So you have to consider the spacecraft is not, it's not just a single point, it's an extended object. Although the telescope, my telescope can't resolve that, it does matter in terms of whether it's reflecting any light or not. Just because the cameras are fully eclipsed doesn't mean that the solar arrays at the edges of the spacecraft are, or the sides of the spacecraft, what have you. But right at about 6:18:54 seconds is where we really saw this dramatic decrease in its brightness. Maybe about 10 seconds earlier it was already starting to decrease, but there was significantly more light. So let me see if I can screen share Deep Sky Stacker here so you can see what I'm talking about. Come back here to Google Hangouts. And you guys get to see my pretty face. Just kidding, it's an ugly face, right? No. There we go. So here is Deep Sky Stacker reviewing some of the last pictures taken. So if we come back to 6:18 and 33 seconds universal time, you can see this box. It's up here in the left corner that appears when I mouse over it. You can see an expanded view, and this is SDO right here. And then 6:18:44 seconds, you can see it's decreasing in brightness. 6:18:54 seconds, and now it's just a faint sort of pink dot. And then it's more or less gone within the next 10 seconds. There's just a very, very small red dot right there. And then 10 seconds later, it's completely gone. There's just nothing visible. And so that matches up quite well with the images that SDO took. So let me screen share that. It's not letting me screen share that? That's weird. It doesn't actually... Huh. Okay, I guess the Windows 10 photo viewer does not play nice with Google Hangouts. It won't let me. Alright, well, I'll just put it in the video description, I guess. Oh, what in the heck? What's this? Something flew through the view. Did you guys see that? Shoot, I wasn't saving those images to my hard drive. It was a gold spike that went through the view. Might have been a meteor. It's probably a meteor. I don't see any planes or anything else. You guys saw that? Huh. See the X-Files thing, right? Okay. Let's see. All right, let me... Okay. All right, I found the direct links to these SDO images that show the progression of that sunset or eclipse. So I'm just creating a list right now of those links. I'll drop those in chat real quick, and then after the webcast, I'll drop them in the video description so that you can have those for comparison. Okay, excellent. So here are the full resolution images. So the way SDO works, there are multiple wavelengths of light that it looks at with different cameras. And so they fire off in succession, which is why you get these different colors, right? And different wavelengths. It's not that there's something draining the sun that's draining it in specific wavelengths but not others. No, it's just that it's a time progression. So I've got these listed in chronological order here, from 6:14 universal time to 6:18:54 seconds universal time, and you can see that whole progression of Earth moving into the image. Oh, well, gee, thanks a lot. Come on. Really? I didn't realize there was such a strict character limit. Okay, I'll have to drop the links one at a time. One, there's no eclipse yet occurring in that image, and then by the next one, you start to get it eclipsed. And then in the next one, it's almost entirely eclipsed. Then in the last one, it is fully eclipsed. Boom. Yeah, Charisse, I saw that gold spike looking thing. I don't know, I just happened to catch that, and I threw it back on screen share. Unfortunately, I was not saving those images to my hard drive, and I'm now kicking myself for not doing that. So the only way it's saved is through the Google Hangout. Fortunately, the Google Hangout will automatically save the full replay. I suspect that might have been a chance meteor that went through the image, because I'm looking up in the sky. I looked up in the sky when I saw that and didn't see anything by eye. So it must have been very, very brief, whatever it was. So kind of cool. We have to see something strange appear there next to the DirecTV satellite. Oh, I can already edit the video description. Hooray. Go ahead and just drop all these links into the video description. Awesome. Well, thanks guys for watching. Somebody says they're looking forward to the development of my tracking software, upgrading to a 16-inch f4.5 in 2 weeks. Well, that's going to be a nice scope, isn't it? So I'm developing my tracking software using, right now it uses the standard LX200 command set. I'm going to be porting it to the AutoStar command set, which should be pretty straightforward. The only tricky thing is for the LX200, newer AutoStar LX200s do allow you to directly set the drive rates. So that basically requires a pretty complete redesign of the tracking algorithm that I use for both satellite, well, pretty much the whole program. But the foundation of the program is there, but I'm going to have to rework the tracking algorithm specifically for scopes, higher end scopes that do allow you to set direct tracking rates. The advantage of the program is that it can be used with systems that are not that advanced, systems that are older, or systems that don't have as many features and do not allow you to directly set the drive rates. My telescope is one such example. That's why there is no solution out there right now that does everything my program does. The telescope you're upgrading to, I don't know what your drive system will be or what command set it will use. It could be some custom thing. The unfortunate thing is I can't use ASCOM drivers. Now, I should put a caveat on that. I can't use ASCOM drivers with the current tracking algorithm. It will not work. ASCOM is too slow. I need much faster feedback rates from the telescope, and ASCOM just can't give it to me fast enough. It might be able to do it with more advanced telescopes that allow for direct drive rate setting. There are commands in ASCOM to provide for that, but they only work with telescopes that accept those commands. It doesn't know how to translate that into older or less advanced telescopes. So once I redesign that tracking algorithm to work with newer LX200s and other scopes that do allow for direct drive rate control, I might be able to then port it to ASCOM as well, in which case, as long as your telescope has an ASCOM driver, which they basically all do, it would work. But that's going to be a little further down the line in terms of the development, probably. It'll probably be ported to, well, frankly, lower end scopes than what you're upgrading to. NextStar telescopes, AutoStar telescopes, and not just like, the high-end NextStars or the high-end AutoStars. I mean, like LX90s and those sorts of things. Yeah, I'm sorry, Sharice. I made that way too complicated sounding, I guess. Well, in astronomy, there's a lot to learn, obviously, with observational astronomy, with operating telescopes, even go-to telescopes. But they do have they do have some pretty cheatsy telescopes that let you sort of skip a lot of the things you should normally learn about astronomy, just the basics. Like, you know, for example, with my go-to telescope, yes, it can find objects on its own. However, when I'm setting it up and aligning it, I have to know the sky. I have to be able to tell it which stars it's pointed at initially. I have to tell it 2 different stars. And these days, they're getting more and more advanced that you don't even have to do that, really. The telescope will point itself to the stars that it needs, and it will identify them itself, pretty much. And they have, like, for instance, the Meade Light Switch telescope. The gimmick or the claim to fame is that you flip a switch and it does everything for you. You don't have to know the sky. And I think Celestron's got a competitor to that as well. But back in the day, even go-to scopes, you had to know your stars. So that's why I always said, you know, that it's always best to start out with a sky chart and binoculars and learn how to navigate the sky yourself. Yeah, Dobsonians are great. They're sort of maximal value for your money. You'll get the most aperture per dollar. Of course, the trick with Dobson, or I guess you'd say that I don't look at it as a disadvantage. I honestly don't. But you know, they don't generally have tracking systems until you get into higher level Dobsonians. I know Orion makes some tracking Dobs. But generally, if you're starting off with a Dobsonian, you need to learn to navigate the sky, learn to read sky charts, learn to star hop. But those are all great skills to have. Those are all important skills to have. So yeah, you know, maybe some night what I should do is, I don't know how to do it exactly, but it would be kind of good, I suppose, to do sort of like an introductory astronomy lesson on how to star hop, how to read a sky chart, how to, you know, identify a deep space object or find a deep space object, something like that. I don't know. That's a little tricky to do with the setup as I have it now, but maybe we can work on that. So thanks, guys, for watching. That's pretty much all I have for you for tonight. Obviously, I'm not set up in a good location for really serious deep sky watching, as you can see by all the glare in the image. But there you go. We were able to see SDO go into shadow. We're able to see other geostationary satellites. So clearly the sun hasn't been turned off. I feel ridiculous saying it, but hey, you know, I'm not the one, not the one coming up with these ideas that these other channels are pushing out there. So that's pretty much it, though. I will upload the sequence of images showing SDO going into shadow with a side-by-side of what SDO saw as it went into shadow. So it's kind of cool. We got to see the Solar Dynamics Observatory go into Earth's shadow, and at the same time, the Solar Dynamics Observatory itself saw the Earth start to block the sun and then completely block the sun. So kind of cool. We definitely solved that mystery and put that one to bed. So thanks for watching, guys. Clear skies, folks.